Welcome to Chapter 10, Section 2, Measuring Angles and Arcs. So remember my recommendation, try to do this first page on your own just by looking at your book and then kind of check your answers with me. So Section 2 starts off with scan the lesson, write 2 facts you learned about measuring angles and arcs as you scan the text. So something maybe like a circle has 360 degrees, and maybe an arc is part of a circle, defined by 2 endpoints. So just like you have a line segment that's part of a line, an arc would be part of a circle defined by 2 endpoints. So label the diagram with the list of terms at the left. So starting with the top left one, it's pointing at this angle here. What looks like B is my center. So this angle here is going to be my central angle because it literally comes from the center. Moving down, this arrow is pointing to this arc, which is more than half of the circle. This would be called a major arc, because a major arc is anything that's more than 180 degrees. Therefore, this portion here would be the minor arc, because it is smaller. It doesn't encompass half of the circle. Here, I'm pointing to 2 arcs that are exactly the same size. These are congruent arcs. Moving down, I'm looking at this arc and this arc. They're next to each other, so we would call them adjacent arcs. And the very last one is pointing to half of the circle exactly. We would call this the semicircle, because it's exactly 180 degrees. So given that the measure of angle EJD is 15 degrees, find each measure and circle J in the order specified and justify your answers. So if we're looking at central angles that come from the center, that means the measure of the angle and the arc are going to be equal because they're coming from the center. So let's start with that. If EJD is 15 degrees, that's this angle right here, that means that arc ED is also 15. This is because the measure of a minor arc is equal to the measure of the central angle. Okay, so is there anything else I know? Well, if this is 15 because the center angle is 15, I notice that this one here has a center angle of 90, which means this arc DH is going to be 90. So this is asking me about arc EDH. Well, that's going to be 90 plus 15, which is 105, because the measure is equal to the sum of the 2 adjacent arcs. Okay, so keep moving along. Well, I'm asked for GH. If I look here, GE is a diameter. It goes through the center. I know circle J is the name, so J has to be the center. That means this entire arc has to be 180 because it's exactly half the circle. The diameter is going to cut it in half. So I can say GH is going to be 180 minus 105, which is 75. And I can write out why EHG G is a semicircle. That's where I got that 180 degrees. So the last one is asking me for EFG. Well, EFG is the other semicircle, so I know that one is going to be 180 as well. I can say it is a semicircle. Since EG is the diameter. So I can solve for the measure of each of these arcs. Now notice the difference here. This says find the length of BC and the length of arc BDC. These we're asking for the measure. So a little bit different. If I'm talking about arc length, you can find the formula for arc length. We know that we can measure all the way around a circle is 360 degrees. We can also measure the distance around the circle by finding its circumference. So if I'm talking about circumference, I'm talking about the length. I can take this central angle x degrees and the radius to find the arc length. Arc length is the portion of that circle over 360 degrees. X is my angle, my central angle, so out of 360, and I can multiply it by 2 pi r, which we learned yesterday. That was my formula for circumference. So if I wanted to find the length of either of these, I could. So we actually need to cross this out because the question's asking us for length, not for the measure. It says the radius of circle A is 5. What is the relationship between the two arcs? So let's start with arc BC. If I'm supposed to find the length of arc BC, I see that the central angle is 100 and I know my r is 5. So I can plug in my arc length formula, 100 over 360 times 2 pi times 5. Plugging that into my calculator, I find that's 8.73 centimeters. Then I can find BDC. Well, BDC is the other portion of the circle. It's the rest of it. So if this angle was 100, the other angle is going to be 360 minus 100, or 260 degrees. So I can say arc BDC is 260 over 360 times 2 pi times 5. And I find that to be 22.69. But I could have solved that a different way. I could find the circumference of the entire circle, and I could have subtracted 8.73 because 8.73 was the part I was not including. So how are these two arcs related? Well, if you add them together, you're actually going to get the entire distance around the circle. And the entire distance around the circle we learned yesterday is not called the perimeter of the circle, but the circumference. So I can say the relationship is that the sum of the arcs is the circumference of the circle. And you could even check that. You could solve for the circumference and say the circumference is 2 pi r, which is 2 pi times 5. You're going to find out it's the sum of those two arcs. It's 31.42. Alright, so that is the end of section